Surd. Surds are the square root of non-perfect squares. They are irrational numbers whose values are unending. Example, we have pi, we have values such as surd 2, surd 3, and surd 5. Now you see that when we take the square root of these values, their answers are unending, which means we'll have recurring decimals. By perfect squares, we talk about numbers that you get when you multiply an integer by itself. For instance, let's say you have 5 multiplied by 5. What do you get? You get 25, right? And then when you take the square root of 25, you have 5 again. So by perfect squares, I'm talking about values such as 4, 9, 16, 25, 36, 60, 64, and all that, 81. So I don't want to go deep into perfect square, but I just want to make sure you have an idea of what we're talking about. Now, why are perfect squares, will I say, essential and special in this scenario? It's simply because their answers will give us a whole number and not a recurring decimal or an unending value. So let's continue. Rules of surds. So for the first rule, talking about addition and subtraction of surd. Okay, let's say we have surd A. So we pronounce this as surd A. You can as well call this square root of A. But why we call it a surd is because the answers are unending. But assuming it's a perfect square, we can use the word square root. So let's say surd A plus surd B. We cannot have a situation where you combine them into a single surd. This is not practical. So we cannot combine them into a single surd. So let's make more sense out of this. So assuming we have surd 2 plus surd 3. It simply means we cannot also have a situation where you combine them into 2 plus 3 and then maybe you want to get 5. No, this is not practical. That's for addition of surd. And likewise for subtraction of surd. Let's say you say surd A minus surd B. You cannot have a situation where you combine them and say A minus B. It's not practical. So when you say surd 5 minus surd 3, you cannot have, so I just have to put this, you cannot have a situation where you say 5 minus 3 so that you can get 2. No, this is not practical. This simply means this is not obtainable when dealing with surds. But how about to have situation such as 3 surd 3 plus 5 surd 3? Now, in this situation, I want you to pay attention to see that we have similar surds in the sense that we have surd 3 here and surd 3. You can simply add them. So this is 3 plus 5 gives us what? 8. And you can just simply maintain the surd. I hope this makes sense to you. Okay, if this is not clear, let's do another example. So let's say you have 6 surd 7 minus 2 surd 7. Now remember we have same surds, so they are similar. In this situation, it simply means we can add or subtract. And here we're talking about subtraction. So you just simply say 6 minus 2 gives you what? 4. And then you can maintain surd 7. Now you see that in so doing, we can simply work on this. Let me just give you a tricky example and then we'll continue. Let's say 5 surd 5 minus surd 5. This looks a little bit complex, but it's the same thing. This is the coefficient we have here is 5, and that of here is what? 1. So 5 minus 1 gives us what? 4. And we'll end up with what? 4 surd 5. So we can simply add or subtract when they are what? Similar or same. You understand? So when they are like terms, let me use that word, like terms. So here we have same surd. But at this very point, we have surd 2 and surd 3. Now, to make things more clear, let's say we have 5 surd 3 plus 2 surd 5. Now, are they the same surds? No. Therefore, there is no condition in which we can combine them. It's not practical. Does that make sense? So let's go to the next one. Multiplication of surd. When we have surd A multiplied by surd B, for instance, you can actually multiply them to A times B. So this is obtainable. We can do this. But for addition and subtraction, we can't do that. So let's say surd 2 multiplied by surd 3. We can as well have 2 multiplied by 3, and then that gives us what? Sod 6. This is practical. Note, different sorts can multiply and give a single answer, but different sorts cannot add or subtract to give a single value. And we talked about this in the previous slides. Okay, so if you find anything challenging or confusing, just pause the video and go back a little bit and then you join us again. So let's continue. Simplification of sorts. Okay, so when simplifying sorts, take this note, look out for two values in which one is a perfect square and the other isn't. So it's essential that when you want to break down sorts or simplify them, one has to be a perfect square. So let's start from the first one we have here. So let's simplify sort 18. Before I simplify sort 18, I want to figure out the factors of 18. So if we can know the factors of 18, then we can be able to break this sort down. And for us to do that, we need to figure out one value that is a perfect square and then the other doesn't have to be a perfect square. So let's say 18. This is how I do it. So 18, I want to look at for all the factors of 18. So I know 1 can divide 18, right? One can divide every number. So 1 multiplied by 18 gives us 18. This is how I do it. So 2 can as well divide 18. So 2 can divide 18. 2 divided by 18 is 9, right? So 2 times 9 gives us 18. So I like this because I'm seeing a perfect square here and this is not a perfect square. So let's continue. Then 3 can divide 18, right? So 3 multiplied by 6 gives us 18. So 18 divided by 3 is 6. Now I have a problem with this number. This is not a perfect square and this is not a perfect square, so I can't work with this. Now what other value can divide 18? 4 cannot divide 18, 5 cannot divide 18. So we are back to 6 again. So we have to say 6 multiplied by 3, then 9 multiplied by 2, and then 18 multiplied by 1. So from this point, we had something like, I used to call it a turn in maths. So virtually what we needed could be found here. So we have seen all the possible values you can combine to give us 18. But we can't work with this, neither can we work with the first one. But we can work with 2 and 9 because 9 is a perfect square and 2 isn't. Like we said, just look for one value which is a perfect square and the other one does not have to be a perfect square. So let's continue. From this point, I can simply say that what? Sod 2 multiplied by 9. So we've broken this down. So all sod, we have what? 2 multiplied by 9. So you can simply say sod 2 multiplied by sod 9. So from here, sod 2 remains sod 2, but the square root of 9 is what? Is 3. So 3 multiplied by 2 gives us what? 3 sod 2. So I just brought the whole number forward and then the sod behind. And that makes sense. So that's just it. It's simple. Let's go for the next one. That is sod 60. So sod 60. So what are the factors of 60? So we're looking at for one being a perfect square and the other one does not necessarily have to be a perfect square. So let's do that here. 60. So 1 can divide 60. 2 divided by 60 divided by 2 is 30, right? And can 3 divide? Yeah. 3 multiplied by 20 gives us 16. And then 4 multiplied by 15 gives us 60. I like this one because this is a perfect square and this one isn't a perfect square. And that's fine. It makes sense. So 5 can divide it, right? So 5 multiplied by 12, right? Should give us 60. Okay. 6, right? 6 multiplied by 10. Okay, there's no need going further. I think this is just what we needed. So one has to be a perfect square and the other one does not necessarily have to be a perfect square. By perfect square, I'm talking about the 4s, the 9s, 16s, 25, right? Yeah, this is a perfect square. What again is a perfect square? 36, 64. What again? Take 81. 40, 49. Yeah, 49. Okay, so let's just continue from here. So at this very point, we have sod 4 multiplied by 15, which is same thing as sod 4 multiplied by sod 15. From here, this is square root of 4 is 2. Then we'll have sod 15, but we can simplify further. So this is what? 2 sod 15, and that is just it. As simple as that. So what you want to do is figure out two values. One has to be a perfect square and the other one does not necessarily have to be a perfect square. Now, when same surds multiply, the result is a whole number. So let me show you this. When we have surd 2 multiplied by surd 2, the result is just 2. That's the whole number. So let's prove this. Why is it so? When you have surd 3 multiplied by surd 3, it's same thing as what? You have a single surd, 3 multiplied by 3, and that's giving you what? 3 times 3 is 9. And then the square root of 9 is what? 3. So instead of you going through this whole process, just know that it gives you the whole number, right? So when we say surd 7 multiplied by surd 7, it gives us what? 7. And we don't need to think about it. And when we say surd 5 multiplied by surd 5, it gives us what? 5. And we don't need to rack our brain about that, right? Okay, so let's go to the next slide. Division of surds. So on division of surd, assuming we have surd such as surd, let's say single surd A over B, we can simply have these surds as what? Surd A then over surd B. So it can come in any form. If they give you value in this form, you can take it to this form. And if they should give you a value in this form, you can as well take it to this other form. Let's do an example and see how it goes. So let's say surd 35 over surd 5. Actually, it is not practical to divide these two values. So what do we simply do? Is in this form. So let's bring it to this form. So we combine them into 35 over 5. You can now divide it. 35 divided by 5 is what? Is giving you what? Is giving you 7, right? Okay, so we just simply have what? We simply have surd 7. Does that make sense? Yeah, simple. So what if a case where we have something like surd 17 over 4. Now is in this other form. Let's take it to this form. You can now say surd 17 over surd 4. So you cannot simplify this. This remains surd 17, and then square root of 4 is what? Is 2, and you're done. So the simple thing here is for you to know what you are being given, and then you know how to move it in the right form and be able to simplify whatever you are being asked. We have some tasks to solve. Let's do that together. So for the first one, we have 4 surd 8 over surd 8. From this very point, we need to simplify surd 8. So for the numerator, the one above, we can have 4, then breaking 8 down. 2 times 4 is 8, right? And then here, same thing. 2 times 4 also gives us 8. Let me continue from these very points. So we can have 4 surd 2 multiplied by surd 4 all over surd 2 multiplied by surd 4. So this very point, you can say 4, let me just multiply everything through. So 4 multiplied by surd 2 multiplied by square root of 4 is 2, and then all over surd 2 multiplied by square root of 4 is also 2. So let's multiply 4 times surd 2, that is 4 surd 2, and then multiply by 2. Remember, this is 4 times 2 is 8. So 4 times 2 gives us 8. So we have 8 surd 2 all over 2 surd 2. So from these very points, what's the next thing to do? You can cancel out the surds since we have them on both the numerator and denominator. So the surds cancel out, and 2 divided by 8 is giving us a whole number of just 4. And that's simple. We are done with that. Okay, let's do the next one. Next one looks a little bit complex, but it's still something we can do. Surd 32 minus surd 98 plus 5 surd 2. So let's simplify 32. 32 is same as 16 multiplied by 2, right? So 16 is a perfect square. That's why I'm using it. So one number has to be a perfect square, and the other one does not necessarily have to be a perfect square, right? Okay, so minus 98 can as well be 49 multiplied by 2. So 49 multiplied by 2 gives us 98. So plus this one has already been simplified. We can't do anything here again. So let's just leave that for now. So here we have 16 multiplied by sub 2. I'm just taking every step one after the other. Then 49 multiplied by sub 2 plus 5 sub 2. Square root of 16 is 4. So 4 sub 2, I'm multiplying 4 times 2. 4 times sub 2 is 4 sub 2 minus square root of 49 is 7. So 7 sub 2 and then plus 5 sub 2. From this very point, you can just simply, do the arithmetic. So you can just simply say, since we have common surd, we can add and subtract. So 4 minus 7 gives us negative 3. Then negative 3 plus 5 gives us what? Positive 2. So we'll have 2 surd 2. But you might as well not like it that way. So let's just arrange from this point. So you can just say 4 sub 2 plus 5 sub 2 minus 7 sub 2. I think this is more clear. This gives us 9 sub 2. The surds are the same, so we can just simply add 4 plus 5 is 9, and then 7 sub 2, and then 9 minus 7 gives us what? Gives us 2, and then we have to add sub 2. And that's just it. So same process over and over again. It's just simple. It's not complex. Okay, we'll have another question here. And it says 10 surd 50 minus 6 surd 72 plus surd 32 minus 2 surd 18. So from here, we need two values, right? And then, so let's go 10 surd 2 multiplied by 25. Yeah, 2 multiplied by 25 is 50, and this is 25 is a perfect square, and then this one does not necessarily have to be a perfect square. So 6, and then 36 multiplied by 2 exactly, or 2 multiplied by 36 is the same thing. The order does not really matter. Then 16 multiplied by 2, 16 multiplied by 2 gives us 32 minus 2 brackets 9 multiplied by 2 is 18. So that's it. From this very point, we can have 10 sub 2. I'm just taking everything directly. Then multiply by 5, because so 25 is same thing as 5. That square root of 25 is 5. Then minus 6. Then this is 6 sod. Okay, let me bring this one forward. Sub 2, because this one cannot be broken down. Then multiply by 6. Square root of 36 is 6. Then plus this one gives us square root of 16 is 4. Then sub 2 minus 2. Square root of 9 is 3. 2 multiplied by 3, and then multiply by sub 2. So you can see that we have sub 2 running across our whole example. So from here, just multiply 10 times 5 is 50 sub 2. So just everything here is multiplied. They're multiplying themselves. Then 6 times 6 is 36 minus 36 sub 2. Okay, plus 4 sub 2, then minus 6 sub 2. I believe you are following at this very point. It's looking a little bit rough, but I think you want to pause the video if you get confused at any point and go through it again. But however, I think the whole process is simple and clear. Okay, so from this very point, what do? We can simply combine and look for a possible way to make things easy, right? So let's see. 50 plus 4 gives us, I want to take this and this, so it gives us 54 sub 2. Then let me take this one now, this and this minus 36 minus 6, that gives us negative 42, negative 42 sub 2, right? So let's go ahead and subtract. Then 54 minus 42 gives us 12. So let's 54 minus 42. This is 2 and 1, exactly. So this gives us what? Gives us 12 sub 2. Don't mind me, sometimes that can be funny, but I believe you understood the whole process, you followed accordingly. That's the most important thing. If you can understand the process, then that makes sense. Okay, so and finally, we have a task for you to do. So the only way you can be able to master some of these things and be able to, go through the process like I did is when you go through these tasks. And one thing about math, math is beyond a subject. It's more than a subject. For me, it's a skill. And the only way you can hone a skill or master a skill is by practice. And that is why it is expedient and it's essential that you go through this question. So look out for the next lesson on rationalization of sorts, and I believe this is going to be an amazing series. Thank you so much for joining. Do well to like, subscribe, comment. Please comment and grow this community. This is an amazing community, beautiful movement. Thank you and have a nice time.